Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we are going to complete the practice test together. I'm going to go one by one. If you have any questions, please stop me. Please don't just cheat. In other words, don't just do what I'm doing on the board. Do the problem while I'm doing it on the board. Then check to see if you did it correctly or not. Now, for some of you who already may have done it at home, great. Does it hurt to do it again right now? No. So everyone should have a piece of paper out. Everyone should have a pencil out. Everyone should be taking this test with me. Okay? If you get it wrong, that's when you ask. So I'm going to stop messing around. I'm going to get right to it. I'm going to solve each equation here using the square root method. Hopefully by now you understand that you get rid of a power of 2 by taking the square root of both sides. So when you take the square root of both sides here, the square root cancels this power of 2. So I have x plus 3/4 equals. I can divide these. This is the square root of 5 over the square root of 16. So this is plus or minus square root of 5 over 4. I'm going to subtract the 3/4 to both sides, and this will give me x equals negative 3/4 plus or minus, I'll make that a little neater, plus or minus square root of 15 over 4. That's it. You're done. Yes, sir. I don't know why I put a square root of 15. It should have been a square root of 5. Thank you, sir. That was my bad. No excuses. Pay attention, Mr. Morrow. That's a square root of 5 clearly. My apologies. All right. Number 2, let me go ahead and split this up so that way I have space and everyone can work that way. Okay. Actually, let me add a, there we go. So let me bring this guy over here. Okay. So I want to solve this by square root method. I want to get rid of this power of 2. So I square root both sides. The square root cancels out the power of 2. I've got negative 2x plus 15 equals plus or minus 12. I'm going to subtract 15 to both sides. My brothers, please be careful here. This is negative 15 plus or minus 12 divided by negative 2. That is not your final answer. You have 2 answers here, hence the plus or minus. So you've got negative 15 plus 12, which is negative 3 divided by negative 2, which is 3/2, comma. Negative 15 minus 12, which is negative 27 over negative 2, which is positive 27/2. If you want to turn them into a mixed number, you can. But that's my answer. Does everyone see this? This would be the time to ask, gentlemen. Not tomorrow during the test. Not tonight at 10 o'clock sending me emails. But today, right now. This moment. Seize the moment. Okay? I'm going to move on then. Okay. Number 3. I want to complete the square here, okay? So number 3, I can erase this side already? Because I want to make it clear for everybody. And again, I don't want to pick on anybody, but I'm asking you very nicely to please go ahead and do this with me. But that's your choice. I want to complete the square. I'm not turning this into a vertex form. I just want to complete the square. So I want to isolate the x squared and the x. So in order to isolate it, I add 7 to both sides. So I've got x squared minus 5x equals 7. So now I'm going to go x squared minus 5x plus b over 2. Your b is negative 5. So this is b over 2 squared equals 7 plus b over 2 squared. Whatever you do to one side, you do to the other side. Yes, sir? No. Whatever I add to one side, I add to the other side. You're thinking of vertex form, son. When we're doing vertex form, wouldn't I have to subtract this value back over here? That's why we subtract it when we're doing vertex form. But let's not confuse ourselves. I just want to solve by completing the square. So I add b over 2 squared to both sides. Great question, son. Thank you. Now we factor it. This is a perfect squared trinomial I created. So this is x minus 5 halves squared. Don't square this value because that's going to be 25 fourths. And then it is going to be difficult to factor that out. That's why that's our little trick. We just put the inside right here. That equals, now we have to do some math, guys. 7 plus 25 fourths. Because a negative 5 says a negative 5 is a positive. So this goes to 4. This goes to 28. So this is 53 fourths. Does everyone see that? Are you sure? Okay. Now I want to get rid of the square, the power of 2. So I square root both sides. The square root cancels the 2. X minus 5 halves equals plus or minus square root of 53 over 2. Now I add my 5 halves to both sides. And I get x equals 5 halves plus or minus square root of 53 over 2. Sir, if you wanted to put all of this over 2, you could, yes. Yes, sir. Thank you, my man. Questions on how to solve by completing the square? Yes, sir. Thank you. No, you do not need to calculate the actual decimal values here. No, no, no. Leave it like that, please, and thank you. If I ever wanted the actual value, I'd say round the answer to the nearest tenths, for example. And then how would you do that? This would be 5 halves plus square root of 53 over 2. Put that in the calculator. And then 5 halves minus square root of 53 over 2. Thank you, my brother. May I continue, gentlemen? Okay. Let's now do number 4. Number 4 is also another completing the square. I'm going to isolate the x squared and the x. So I've got x squared minus 6x plus b over 2 squared. I have to bring over the 17, so that's negative 17, plus b over 2 squared. This factors out to be x minus 3 squared, and this equals negative 17, not 19, plus 9. This is x minus 3 squared equals negative 8. Yeah. No. Yeah. No. Yes. So, sorry, I had a little problem there. Okay. Yeah, it is. Sorry, I don't know why. Okay. Square both sides. x minus 3 equals plus or minus. This breaks up into 4 times 2. Square root of 4 is 2. So this is plus or minus 2I square root of 2. Add the 3. X equals 3 plus or minus 2I square root of 2. And that's how you solve by completing the square. Does that make sense, gentlemen? Okay. Next, solve each equation by using the quadratic formula. Okay, this should be Mickey Mouse. You first must put it into standard form. So this is 2x squared minus 4x minus 3 equals 0. Like I've told you before, label. 2 is the A. Negative 4 is the B. Negative 3 is the C. Negative B plus or minus square root of B squared minus 4 times A times C over 2A. This gives you 4 plus or minus. You've got 16 because negative 4 squared is 16. Negative 4 times 2 is negative 8. Negative 8 times 3 is 24. 24 plus 16 is 40 over 4. This 40 breaks down into 4 times 10. Square root of 4 is 2. So this is 4 plus or minus 2 square root of 10 over 4. Be careful here. This 4 divides to this 4 and to this 2. 4 divided by 4 is 1, so I could put a 1 there. Plus or minus square root of 10 over 2. Only the square root of 10 is being divided by 2 because 4 divided by 4 is 1. Talk to me, boys. This is the time to talk to me. Right now, sir. If you left it like this would not be wrong. But this is what a lot of you did on the previous exam. Oh, this is 1 plus or minus square root of 10. And that is wrong. This 4 goes to the 4 and the 2. So 4 over 4 is 1, but 2 divided by 4, that's 1/2. That denominator stays under the square root of 10. Yes, no, maybe, kind of, sort of. All right. I'm going to erase it. Yes? All right. Yes. Come again, son? If you factored out a 2 out of everything, then it would be 2 plus or minus square root of 10 over 2. Yes. That would not be marked wrong. We already said that, but thank you for asking again. If you left it like this, it would be correct. If you left it like this, it would be correct. If you left it like this, it would be correct. So before I erase it and have to go back again, are there any other questions? Thank you. Are you sure, guys? Are you sure, guys? Okay. Thank you, my brothers. No, I don't mind questions, guys. I just, when I ask you and you say no, and then after I erase it, you say yes, it just drives me bananas. But okay. Thank you. Now let's do this guy. First, like always, we have to put it in standard form. 9x squared minus 24x plus 16. By the way, this is when a calculator comes in really handy. Negative b plus or minus b squared minus 4 times a times c divided by 2a. Now, I know you can do this by yourself without a calculator, but engineers have calculators, and in a question like this, why would I not let you use a tool? So this is 24. As you can see, I'm even going to use the tool. It's not a big deal. Okay, so 24 squared is 576 minus 36 times 16 is 576. So this is 24 plus or minus 0 over 18. So this is just going to be one answer. I can divide 6 to both top and bottom, so x equals 4/3 only. Questions, comments, concerns, anything you need at all, because this is it for the first page. Anything else at all? Anything? Are you sure, guys? All right. Let us continue, brothers. Thank you. Okie dokie, Smokey. Let's do this one. I want you to just solve the equation. Okay. In this case, we have these funky exponents, so we know we're going to do substitution. So the first thing I want to do is make sure I label my substitution. I'm going to say that u equals x to the 1/3. So 1/3 squared would be 2/3, so this is 2u squared plus 13u minus 7 equals 0. I'm going to cube and method it up. 2u, negative 14. What times what is negative 14? What I have to get is positive 13. 14 and negative 1. Artificial factor of 2. U plus 7 times 2u minus 1 equals 0. So u equals negative 7 and u equals 1/2. You're not done. U is equal to x to the 1/3. So really, x to the 1/3 equals negative 7, and x to the 1/3 equals 1/2. I'm sorry, my brother? You now multiply, but you're going to raise it to the 3rd power. Correct, sir. So, am I right in saying that's 343? Negative 343, comma, when I cube both of these, I get 1/8. Talk to me, my brothers. Now's the time, guys. You have all the work right here from start to finish. If you have a question, talk to me. Sir, thank you. U is always going to equal this middle x term. Not the b, but the middle x term. U will always equal that. Thank you, sir. Any other questions? That was a great question. Thank you. Going once. Twice. I'm going to erase. That means I do not want to go back, guys. So ask now, please. Okay. Here we go. All righty. Let's do it. Solve this inequality algebraically. Okay. Okay, this is a good one. I did this on purpose. We're going to factor this, but hopefully you guys realize this is a perfect square. Square root of this is 2x. Square root of this is 5. 2 times 5 times 2 is 20. Oh, wait a second. So this is simply 2x minus 5 squared is greater than or equal to 0. So we got to solve for x here. X is going to equal 5 halves. We have to do a little test value, guys. 5 halves. Okay. It's either going to be to the left, to the right, or neither, right? So let's go to the left. Let's plug in if x is 0. If x is 0 here, 0, 0 is 25 greater than or equal to 0. So that works. Let's do it to the right. Let's do, I don't know, 3. Okay, 3. 3 squared is 9. That's 36. 36 minus 60. What do you mean? 5 halves is 2.5, guys. What are you talking about? If I go to the right here, guys, and I put a 3. Right, I'm testing a 3. 3 squared is 9. 9 times 4 is 36. 36 minus 60 plus 25. Is that greater than or equal to 0? Okay. 56, guys, and 25 is 61. 61 minus 60 is 1. Yes, sir. The answer is not obviously going to be all real numbers. What if I had done less than 0 here? Then it would have been no solution. Okay? So no. Thank you for saying that, but that's not obvious. That's the problem. Test it. So when I add this, guys, 1 is greater than or equal to 0. So in this case, this is all real numbers. All real numbers. Okay? Now, let's just give you guys a different one, just to show you when it's not all real numbers. Let's say, for example, instead of this guy, I give you, I don't know, I'm just going off the top of my head, x squared, let's see, minus, minus 8x plus 15 is less than 0. Okay, try to factor this. So what times what is 15? What I have to get is negative 8. Negative 3 and negative 5. So I've got x equals 3 and 5, right? So I've got my 3 and I've got my 5. It's testing to the left, in between, and to the right. When I test to the left, I'm going to put in 0. Well, I got 0, 0 plus 15. That's 15. Is 15 less than 0? No. Between 3 and 5 is 4. 16. 16 minus 32 is negative 16. Negative 16 plus 15 is negative 1. Is negative 1 less than 0? Yes. Let's go to the right. Let's do 6. 36 minus 48 plus 15. That's 51. So 51 minus 48 is positive 3. Is that less than 0? So my answer is 3, 5. Why is it not in brackets? Because it's less than. Does that make sense, sirs? Yes, sir. I don't understand what you just meant by can you just put 4? The solution is not 4. The solution is anything between 3 and 5. It could be 3.162, 3.7, 3.5, 3.8, 4.9, 4.6217, 4 3/3, 4.999. So no, if you put 4, I'm going to mark it wrong because that's not the answer. It's between 3 and 5. Yes, sir. I just made this up. Where did I get this? I made it up. I made it up. Does that make sense, boys? Sir? Yes or no, guys? We got to keep going here. You sure? Okay. Let's do number 9 now. Rational inequalities. Okay, for rational inequalities, we're going to set the top equal to 0. So x can equal 5. And we're going to set the denominator not equal to 0 because I cannot have a 0 in the denominator. So x cannot equal negative 4. Okay, so here's my negative 4. Here's my 5. I got to test to the left. Got to test in between. Got to test to the right. Let's test to the left. To the left, let's do negative 5. So that'd be a negative 10 over a negative 1. A negative divided by a negative is a positive. Is that less than 0? No. Let's do 0 for in between negative 4 and 5. That's going to be negative 5 over 4, which is going to be a negative because a negative divided by a positive is a negative. Is a negative less than 0? Yes. Let's go to the right of 5. Let's do 6. 6 minus 5 is 1 over 10, so that's a positive. That is not less than 0. So in this case, it happens to also be the middle. It's not always going to be the middle. Remember that, guys. Please don't think it's going to be the middle always. Yes? If the left doesn't work, the right usually doesn't work. Correct. Sir? I'm sorry? Remember, we're just doing this equal and no, it won't equal 5. That's why I put a parentheses. Well, why did I put equals 5 there? To first set up our limits. Yes, sir. If it was less than or equal to 0, then the 5 would be in brackets. The 4 would not be in brackets, though, because if I had x is negative 4, the denominator would be 0, and that's undefined. Thank you, sir. Does that make sense as well to you, Paul? If it said less than or equal to 0, you'd have a bracket around that 5. Yes, no, maybe, kind of, sort of. Okay. Now, this is what we did yesterday for our quiz. You got to, first of all, with all due respect, read directions. It asks you to put this in vertex form, then graph it, then give me the axis of symmetry in the vertex and the range and domain. So, to do this in vertex form, f of x equals, isolate this the x squared and the x. This is x squared minus 7x plus b over 2, which is negative 7 over 2 squared. This plus 10 steps aside. Minus the b over 2 squared. Do not multiply those two negatives. Follow order of operations. So this is going to be x minus 7 halves squared. This is 10 minus 49 fourths. This goes to 4. That goes to 40. So this is minus 9 fourths. That is my vertex form. Talk to me, guys. Please. Okay. So my vertex is 7 halves, comma, negative 9 fourths. My axis is the x value of the vertex, so 7 halves. My y-intercept, because I need it to graph, is the standalone 10. It's the constant. So that'd be 0, 10. And now I can graph it. Now I can graph it quite easily, actually. It's going to be not a super perfect graph, but we got time here to worry about. Okay, so my axis of symmetry is 7 halves or 3.5. So I'm going to go down here 3.5. 3.5 negative 9 fourths is my vertex, so that's negative 2.25. So 1, 2, and a little bit will go right there. My y-intercept is 0, 10. You go by 2s or 5s, whatever you want. So I'm going to go by, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is a half and 3 to the left. So go 1 half and 1, 2, 3 to the right. It's graphed. Done. My domain is all real numbers. My range, the lowest part of this graph is negative 9/4. So it's bracket negative 9/4, and it goes up from there to positive infinity. Questions? Yes? The y-intercept, you can do that two ways. You can plug in 0 for x here and solve, or isn't the y-intercept the y value when x is 0? It's the constant. Thank you. Any other questions, guys? Yes, sir. Yes, the x is always the opposite in the vertex because the formula is x minus h. So it's always opposite. Thank you so much. Thank you. Good questions. Anything else here, boys? Tick-tock. The clock is running. I don't mind questions, but let's go. Yes or no? Okay, I'm going to move on then. All right. Now, for this guy. Okay. First thing I want to do is isolate. So I'm going to get 2x squared minus 8x. I'm going to leave a space and put this plus 5 over here. I have to factor out any a that is not 1. This is my a. So I'm going to factor out a 2, giving me x squared minus 4x plus b over 2 squared. This is my b. So b over 2 would be negative 2 squared plus the 5. Now, pay attention. Minus the a that I factored out times the b over 2 squared. Again, minus the a that I factored out times the b over 2 squared that I added to the interior. Are you feeling me? So this is going to be f of x equals 2x minus 2 squared. Okay, negative 2 squared is 4 times a negative 2 is negative 8 plus a 5 is negative 3. My vertex, 2, negative 3. My axis of symmetry, x equals 2. My y-intercept, 5. And then, to save time, guys, I'm not going to graph it. Is that fine? Hopefully you know how to graph it. Yes, sir. The negative, I don't know what you're saying. The negative goes along with it. It's 5 minus 2 times negative 2 squared. Negative 2 squared is 4. 4 times negative 2 is negative 8. Plus 5 is negative 3. Are you sure? Everybody, are you sure? Okay. Now, okay. Gonna have to speed up a little bit. So you can still ask questions, but I'm gonna speed up. And remember, we do have a video. Okay. Let me get rid of this. All right. Here, read directions, please. Solve the quadratic function. Solve the quadratic function. Okay? So when we're solving the quadratic function, we got to first try to factor, complete the square quadratic formula to find my x-intercepts. So it's going to be x. What times what is 5 when I have to go is negative 4? Negative 5, positive 1. So x equals 5. That's right. You can't do that. So not necessarily not unfactorable. Quadratic formula. Negative b plus or minus b squared minus 4 times a times c over 2a. Okay, so I've got 4 plus or minus square root of negative 4, right? How many real solutions do I have when there's a negative inside the radical? None. So what are my x-intercepts here? None. Good. Okay. I can still graph this, though. It just means it's not going to cross the x-axis. So what? My axis of symmetry is negative b over 2a. So in this case, it's going to be 4 over 2, which x equals 2. That's my axis of symmetry. My vertex, I plug the x of the axis of symmetry into the function. 2 squared is 4. 4 minus 8 is negative 4. Plus 5 is 1. So 2, 1 is my vertex. My y-intercept is 0, 5. Do I need to graph it? You got this? Promise? Yes, sir.
I didn't understand. The 4 plus or minus square root of negative 4 over 2. Like, I don't get what you're saying about there not being an x-intercept.
There's a negative inside of the radical. Didn't we learn about the determinants? If the inside of the square root, if the discriminant is positive, there's 2 solutions. If it's negative, there's no solutions. It's going to be an imaginary number. This is not going to cross the x-axis. There are no solutions. So there are no x-intercepts. There is a graph, but it's not going to be going through the x-axis. Yes, sir.
Let's say instead of putting score in there, like positive, would you still have to like calculate it, like find the x? Like let's say like 5 was in there, positive 5.
Okay, let's say there was a positive 5 instead of a 4. You do have a calculator, right? So then you'd have a decimal answer for your x-intercepts. Thank you, sir. Anything else, gentlemen? Yes, sir. Yeah, I can skip this one, the next one. That's fine. You guys okay with that? Huh? Talk to me, guys. I've got 10 minutes left. And the test is tomorrow regardless. So do I skip this next one or not? Skip it? Okay. Yeah, guys, that's easy. You just put it into the quadratic formula. And then negative b over 2a, and that's Mickey Mouse. Here, determine whether the quadratic function has a max or a min value. Find the max or a min. Do not graph, please. Please do not graph. Let me just show you. It's real quick. Please do not graph. First of all, it's going to be a maximum because it's negative. It's going to be pointing down. So you have a max. You have to find your vertex. The max value is the y value of the vertex. So negative b over 2a. Come on now. Don't mess up on me now. Oh, goodness. Great. There we go. Okay. So that's going to be negative 6/8. Why is it lagging? Negative 6/8. Uh-oh. Okay, negative 6/8, which equals negative 3/4. Now, guys, negative 3/4, you've got to plug into every x value here. Okay? You do have a calculator, but you don't need one. This would be negative 4 times 9/16 minus 6 times negative 3/4 plus 1. Put it into your calculator exactly like that. Don't do it in piecemeal. Do it exactly like that. So this is going to be negative 9/4 plus 18 over 4 plus 1. That's 9/4 plus 1. 9/4 plus 1, I'm going to convert to 4 over 4. That equals 13/4. So it's negative 3, 13/4. This is a maximum, and the maximum value is 13/4. Got to know how to work with your fractions, guys. Yes, sir. No, the formula for maximum is not negative b over 2a. That is the formula for the axis of symmetry. Negative b over 2a gives you the x value of the axis of symmetry. Once you have the x value of the axis of symmetry, you plug it into the x value of the function and find y. Yes? Okay. Now, word problems. Okay. Very simple word problems. Now, we've already done some of these already in class. I wish you would have paid attention to it back then. But it is what it is. 15. The area of a triangle is 35 square inches. The height of the triangle is 2 inches less than the base. What are the base and the height of the triangle? Well, area of a triangle equals base times height divided by 2. 35 is my area. The base and the height, they say that the height is 2 inches less than the base. Base is unknown, height is x minus 2, so x times x minus 2 over 2, multiply 2 to both sides, 70 equals x squared minus 2x, subtract the 70 over, x squared minus 2x minus 70. I'm going to have to use the quadratic formula here, so negative b plus or minus the square root of b squared minus 4 times a times negative, so c over 2a. So that's going to be 2 plus or minus the square root of 4 plus 280. So that's 284 over 2. I'm not going to do the math here, but on your calculator, you're going to do 2 plus square root of 284 equals divided by 2. And then 2 minus square root of 284 equals divided by 2. Only the positive answer is going to work. Yes, no, maybe kind of, sort of, guys. Yes? Okay. Here we go. Number 16. Max decides to go on a canoe trip 4 miles upstream. Hey, this is a distance problem. So we got upstream and downstream. Rate times time equals distance. Max decides to canoe 4 miles upstream on a river to the waterfall and then canoe back. The total trip, excluding time spent at the waterfall, was 6 hours. If Max knows he can canoe at an average speed of 5 miles per hour in still water, what is the speed of the current? Okay. So, upstream, guys. Upstream. He's going with or against the current. Okay? So, he canoes 4 miles upstream. So, it's his speed of 5 miles per hour minus the current. Then he goes back, right? So that's another 4 miles, correct? Downstream, so he's going his 5 miles per hour plus c. Now, do not put another variable here for time. Time is distance divided by rate. So 4, 5 minus c, 4 over 5 plus c. The distance, the time that it took him to go upstream plus the time that it took him to go downstream, that round trip was 6 hours. Now, we've done this already. Now you're going to multiply everything by 5 minus c times 5 plus c to both sides. That's the difference of squares. So to make my life easier, I'm going to put here 25 minus c squared. So the 5 minus c cancels here, and I have 4 times 5 plus c, which is 20 plus 4c. The 5 plus c cancels here, so I have 20 minus 4c. And this equals 25 times 6 is 150 minus c squared. I got to create a trinomial here. So I'm going to bring over the c squared. These 4 c's cancel. I'm going to bring over the 150 as a negative. So I have 40 minus 150, which is negative 110 equals 0. And then from here, I can add the 110 to both sides. C squared equals 110, square rooted. C equals plus or minus square root of 110. Calculator in your calculator. and round to the nearest tenths. The negative one does not and will not work. Last but not least, I don't know if I have time to finish it, but at least I'll set it up. Robert and Patty have a newspaper route. When they work together, we're doing a work problem here, correct? So when we do a work problem, we have to set up our little table as well, correct? Okay. So then let's check it out. All right. Hold on, let me just see here. Yes, sir. There's a typo? Is there a typo? Okay, sorry. Instead of together, it said together. You should worry about your math and not my typo, but I do apologize. Anyways, so I'm going to set up my table here. Rate times time equals work. Okay? You with me here? Okay. We got Patty and we got Robert. Okay. It says here that when they work the route together, it takes 2 hours to deliver all the newspapers. So when they're working together, it takes 2 hours. Okay? However, on one morning, Robert told Patty he was too sick to deliver the papers. Patty doesn't remember how long it takes her to deliver the papers, working alone, but she does remember that Robert can finish the route 1 hour sooner than Patty. So Patty does it 1x of the job in an hour. Robert does it sooner. So 1x minus 1 of the job per hour. You with me here, guys? Yes, sir. Okay, because doesn't Robert do it in 1 hour less than Patty? So let's say Patty did it in 8 hours. That'd be 1 over 8, correct? Wouldn't he be 1 over 7? So she does it in 1 over x. He does it in 1 over x minus 1. He does it 1 hour less than her. Because, well, this is from the way we learned how to solve work, guys. Let's say she does it in 8 hours. Doesn't she do 1/8 of the job in 1 hour? But that's why we do it over 1. So my work done here, Patty's work is 2 over x. Robert's is 2 over x minus 1. So Patty's time to do the work plus Robert's time to do the work equals 1 complete job. And then you're going to have to solve this on your own. Okay? Very simple. Do what we did before. You're going to use the quadratic formula. And good luck, guys. Have a great day. Hope you learned a lot. Great questions. Bye-bye.